Issues relating to Cisco IP phones. As you can see in this topology that I have already coupled, you can find that this phone is off. Every phone here is off, so I'm going to give it their designated numbers. This one is going to have an extension of 1000, 2000, 3000, then 4000. On this topology, I have not configured anything. I'm going to show you how a Cisco IP phone boots. Before it operates, the process it undergoes before its life. So this is it. I'm going to configure this topology from start up to the end until I show you that it is working. Then I embark on the troubleshooting aspect. Now that the phone is not booting, what are these aspects that may lead to that? So in enterprise networks, these are the labs or the tasks that you may come across. So the first thing here, I'm going to create, now that I'm just using one switch, the entire switch ports are on the voice VLAN. So, and this voice VLAN is going to operate from this particular subnet, as you can see here, /24. That one translates to a total of 254 usable IP address. Then this is the gateway that will be assigned to this interface fast Ethernet 0/0. This router is a special router. Any router here, let me show you something. When you click on network devices, you will see routers. These routers do not support the CME, call manager. So in VoIP, in Cisco Packet Tracer, there is a special router that is used to achieve that, and that special router is found here. You can see miscellaneous. Under miscellaneous, you will find 2811, 2811. So these are the routers that support the call manager capability or the telephone service capability. But these other routers do not support. But when you are in real network environment, the advanced routers have such capabilities. This is the limitation with the simulation. So let me create VLAN, then assign this switch ports to that VLAN. In this case, even there is no need of creating VLAN because all those switch ports are in VLAN 1. So I can do this. Click on the switch, move to enable, configure terminal, set the switch, voice _ switch 1. After there, already VLAN 1 is created, but let me, for security purposes, let me not rely on VLAN 1. Create VLAN 10, name, voice, exit. That is the steps for creating VLAN. Then this is the step for assigning switch ports to that VLAN interface. Now that I'm going to assign multiple interfaces to that particular VLAN, I use the word range here. But switch ports, interface, fast Ethernet 0, 1, 2. Let me give it 10. Switch port, access, VLAN 10. It's not access. Let me remove this. When you say access, that is a data. So switch port, voice VLAN 10. Then I'm done. I'm done configuring that voice VLAN and assigned interfaces. Then I save my configuration. As you can see, show VLAN 10 is created here, voice, and is given this. So 11 to 20. I'm going to shut those ports down. To shut the ports, this is the steps: interface, fast interface, range, fast Ethernet 0, 10, up to 20, up to 20, shut down. The ports are shut down. The moment I shut down, we should see, you can see, so that is it. So I'm done with configuring the voice VLAN here. Let me configure the call manager. On the call manager, I'm going to assign the IP address on this interface. That's the first step. Second step, I'm going to enable the call manager service here by creating directory numbers and stating the maximum number of IP phones that I have. In my case, I have 4 phones here. Then the last bit is assigning the numbers or extensions to those phones. So no, enable config terminal hostname call underscore manager router 1, then interface first Ethernet 00, IP address 192.168.10. It's 10.1.255.255.255.0. No shutdown. Description. Voice VLAN 10. So I'm done. The next step, we enable telephone service. After enabling telephone service, I defined maximum ePhone, that is, I have 4 phones, then maximum direct numbers, then 4 of them. After that, the next step, the way phones will be mapped to direct numbers. So I want it to be dynamic, so auto assign 1 to 4 because I have 4 phones. After there, I put this command IP source address 192, that is, I give it the gateway of the call manager, that is 1 port 2000. That is just that particular command, it uses this port and this IP address to connect the phones to the call manager. So after having done that, I exit, then I come back to the global configuration mode, whereby I now start configuring the direct numbers and map to respective extension. So ePhone, so that is it. You can see this is the command that I'm using. You see ePhone, configure ePhone and phone lines. So we use that. I can just copy or proceed to type ePhone-dn, then 1 means I'm tackling with phone number 1. Then the moment it's up, you see that directory is up 1 to 1. That is the aspect of this particular line here, dn1.1. it is achieved by the aspect of this command auto assign, this one. So it is mapping direct numbers to phones dynamically. After that, then number 1000. Then I repeat the same. You can use the up arrow to come back to the previous command. Number 2, number, that's 2000. Use up arrow, scroll back to the previous command. You change that to 3. Then number means the extension or the number for that particular phone. Then 4, number 4000. So I'm done configuring the call manager. That is how to verify that you've configured indeed. You can say show running config, then you can see the host name is well configured, the interface, this is the interface, it's well configured. Then down here, this is how the call manager has been configured. You see the telephone service is enabled, maximum number of phones specified, maximum direct number specified. The call manager is linked to phones through that particular IP address, and remember this is the gateway. Okay, then the dynamic assignment of direct numbers to numbers using this command. Then after there, I start assigning every phone with its dedicated extension number. So this aspect in real environment is managed by TFTP, Trigger File Transfer Protocol Server. So that is it. But in this simulation scenario, the call manager, this router handles everything. So that's what I have done. Then the next thing, I'm going to create the DHCP pool for this voice VLAN. So to create data, configure terminal IP DHCP pool, then voice VLAN 10, then default router, I give it the gateway, the first IP address from that subnet. Then next I specify the network 192.168.0. That is after there, and then there is this command option 150, then IP, still the gateway. So without this particular command, the phones will not locate the call manager. Note that. Then DNS, I can just give it the one for Google. Then I'm done. After doing that, then I enable this router to be serviced to give the DHCP functionalities using the service DHCP here. Okay, write memory. To disable this kind of errors in Cisco Packet Tracer, you go to configuration terminal, then you put this command no IP domain lookup. I'm done. So this command only works when you want to disable some errors that the router tries to interpret as if it is domain name. So you disable that domain lookup process, you disable that. So after here, the next step is now I'm going to power on my Cisco phones, and to power these phones, you click on the phones, you come on the physical tab, then you take this adapter. Remember, in real environment, phones are powered through PoE using an Ethernet cable, but in simulation, that is how we power. The moment I take the adapter and put it into that terminal, this particular link turns green. Let me do that a bit faster. So this is a simple app that I'm going to use to show you how to troubleshoot the booting process, or the process that Cisco phones undergo. You can see it is stuck in configuring IP. I will let you know at what stage is that phone, or the phone reaches in that state, what happens in the router. So the moment let me restart this router, and you can see the process. You can see the phones are mapped to their respective direct numbers. After that, will give you the steps. Even the steps are here. You see, the moment you power on, the phone discovered the voice VLAN via CDP. CDP means Cisco Discovery Protocol. This is the protocol used in VoIP to discover the VLAN onto which the phones are linked to. Then after there, it checks the DHCP request. It checks the DHCP request, means it tries to locate where the DHCP server is, and in this case the call manager is serving the same way as DHCP server, so it just takes the IP address, then it assigns to the phone. Once the phone receives the IP address, there is this option, receive option 150 TFTP IP. So this option is what links the phones to the call manager so that it can get IP address, and the call manager should have the DHCP server already configured for it to work. Then after that, download the config from TFTP. In this case, this router is serving as TFTP server. TFTP server, this is Trivial File Transfer Protocol. This is a protocol that is installed on computers so that those computers serve as servers. So the configuration file that is downloaded from this particular call manager is the numbers that I have assigned here with their direct numbers. Can see, check. So the things that are downloaded here is the way the direct numbers are mapped to the phones, the IP addresses that individual phones have been assigned. Then another thing is the gateway. So that is the information that is downloaded from this server. After that, then it registers. Once the above 5 lines are met, or the 5 requirements are met by the call manager, then the phones register with the CME. That's the call manager now. It connects. In general, it connects. Then after that, then you are ready to make calls. Now let me check where you see still stuck in configuring IP. You can realize that on this switch I created VLAN 1, but VLAN 10 is not being seen. It's not seen here. So I can do this. Just to make, you see, I have factory reset the switch. Config interface range, first Ethernet 01 to 24. Let me put all of them to switch port voice VLAN 1, switch port mode access, then end. Let me check what will happen. You see, my phones already have registered, so it has passed through all these processes and it has gotten now the IP and the phone number, as you can see. So I did not exclude the IP address here. Let me exclude, enable, config, IP DHCP pool, excuse IP DHCP, exclude IP address. This is the first IP address to the, let me exclude first 90 IP address, so it will start with the 91, then write memory. From there, let me reload my router. Then observe what will happen. Observe what will happen here. You can see the moment the router boots, you see it discovered the voice VLAN. The links here, you can check here what's happening. Then let me check with my phone. You see it is in the status of configuring IP. So it is syncing with these particular steps here. So just check, let's just be patient and observe. The moment this particular step it moves from configuring IP, then it will get the IP address, and in this you can see the phones have registered, but my screen here it is blank. It has already gotten the 2000, so it has registered. You can see here. So on the call manager now the phones is only taken to have, it is only said to have registered if it gets the IP address, as you can see, because without the IP address there is no communication. So this one it has passed all the stages. Now let's embark here to troubleshoot this, to troubleshoot this particular lab. Let me confirm that one is 1000. So my 1000 is this phone because it is dynamic. That is 1000. This one is 3000. This one is 2000. Then this one is 4000. Then so that is it. So let me call. So this is having 4000. Then when I come to this phone is having 1000. So let me call. So let me call 4000 here. You see the phones are ringing. So the steps here is that the steps to troubleshoot this lab. First of all, ensure that your Cisco phones are powered on, like this one. The moment I, like for example here, let me show you, these are the cases. The moment I remove this adapter, then check, you see device must be powered first. So if the phone is not powered, there is nothing that will happen. That is one case. Two, ensure that the voice VLAN is well configured. In my case, the entire switch is coupling, it is encompassing VLAN 1. So all switch ports are going to be under VLAN 1 and my voice VLAN is VLAN 1. So for demonstration purposes, I haven't not bothered to configure any other VLAN here. So ensure that your phone is up. Then ensure that your voice VLAN is well configured. And there is this command that you should not forget. Let me show you. Show running config. This command, switch port voice VLAN. When you fail this command here, the Cisco IP phones will not be able to locate the call manager because it will find itself in the data VLAN, in data VLAN, that is. So another thing here, it's on the call manager. On this, don't forget switch port voice, then VLAN number that you've chosen. On this call manager, do not forget option 150 when you are configuring the DHCP server. Also, when you do not fail to assign the respective phone numbers and directories on this call manager. So let me show you a simple. These are the steps. You can see when you power on a Cisco IP phone, phones are powered through PoE, power over Ethernet. That is the power adapter that you've seen me moving it from this section. So you see, that is PoE, power over Ethernet. So the first step is you power up stage, where the phones receive power through the PoE, then power over Ethernet, that is. Then in the normal environment, the phone screen lights up. Then to LAN discovery, voice VLAN assignment, and these are how you can configure your VLAN. In my case it was 1 because I'm using the entire switch, it's not segregated. So interface first Ethernet 01, in my case it was multiple ports, so you use the word here range maybe to 24, that is. So don't forget this command. It's one of the crucial commands when it comes to voice VLAN. So stage 2, LAN discovery. Stage 1, I said that you power the phone. Then stage 2, ensure that LAN is discovered, and it will only be discovered when you've properly configured it. You can see here what happens. PC traffic goes to the data VLAN. In my case there is no data VLAN, so there is no need of this section. I'm concerned only with the IP phone traffic, so it will go to voice VLAN, and this is the command that will facilitate this. Then the switch advertises the voice VLAN using the SDP, Cisco Discovery Protocol. The phone listens for this protocol, then it checks, it moves into the voice VLAN. Then step 3, the DHCP request. In this case, now the phones undergoes what we call DORA: discover, offer, request, then acknowledgement. Go and read about this, but I can let you know that this is the aspect that is mostly used in DHCP servers, where clients discover the DHCP server, then they request the offer, then once the offer is given, then the clients acknowledge. So this is the process through which DHCP server goes through or to assign the IP address automatically. So this is step 3. And in that step 3, we expect the IP address to be assigned the subnet mask, the default gateway, and TFTP server. In my case, this is the router, that is the call manager. And this is how you configure the DHCP server for voice VLAN. Let me bold it so that you can see. IP DHCP, then the name of the pool. Network, you specify the network. Then default router, this serves as the gateway. Then this command here, this command is very powerful when it comes to configuring the DHCP server. So that option 150 tells the phone where the CME server is located. Without this, phones get IP but cannot register. So a question can be posted for those preparing CCNA 1 or CCNA certification, that what happens when the phone has the IP but is not registered. So the aspect is for option 150. There is also option 66. Option 66 is used with the phones that are not from Cisco company. I mean other vendors' phones. That one uses option 66 to communicate with the call manager, but Cisco proprietary phones uses option 150. You can research about that. Then conduct TFTP. TFTP, it is just a section within a call manager that stores the configuration file, and in this case configuration file just composed of the directory numbers, the extension numbers, the IP address as assigned. That is it. Also, it checks the firmware status. If the firmware status is not up to date, you will have issues with your phone. Then the call manager information is picked. So these are the steps. The last step, then it conducts the call manager for registration. Once the configuration file is downloaded, then there is this protocol, Cisco Call Manager, Cisco Call Manager Express. These are the things you should know as CCNA is concerned. So this is the last aspect of configuring telephone service in Cisco router. Remember these troubleshooting steps. You should understand at what stage you are at, what is it that you are supposed to do at what stage. At stage 1, powering the phone, what is it that you should do? Stage 2, voice VLAN discovery. How does it occur, or how does it work? So that is it. The last step is step 5, where it conducts the call manager. Conducting the call manager, it just authenticates the files that have been downloaded, registers the phone, then successful. So when it is successful, you will see that the phone displays the extension numbers, the phone shows registered. So in my case simulation, the phone shows registered. You can see it in the router. Then the aspect of calling the IP phone I had already shown you. So these are the steps for troubleshooting the booting process of IP phones in Cisco Packet Tracer. Feel free to subscribe to NetLabs Hub if this particular lab has helped you greatly. Also, I'm open for collaboration, for questions, for critiques, and any other. Thank you.